This question is from GATE 2015 Mechanical Engineering Paper Set 1, question number 14. Consider a slider crank mechanism with non-zero masses and inertia. The constant torque tau is applied on the crank as shown in the figure. Which one of the following plots best resembles variation of crank angle theta versus time? Let's find out. So we need to find out the relationship between theta and time. So crank angle theta is a function of time, and we have to find out the exact relationship between them so that we can figure out which of the graphs represent their relationship. We know that torque tau is equal to mass moment of inertia I into angular acceleration alpha. In the same way which force is equal to mass into acceleration, torque is mass moment of inertia into angular acceleration. Now, angular acceleration can be written in terms of angular velocity. So, we can write I into d omega by dt. And then angular velocity can be written as time derivative of theta. That is angular displacement. So, I into double derivative of theta with respect to time. Now, we can see that we have both variables theta and time here. And if we integrate this, we can get theta in terms of time. So after rearranging, we get tau by I equal to d2 theta by dt square. And then integrating both sides, we will get tau by I into t plus constant of integration, let that be C1, is equal to d theta by dt. We need to integrate this one more time. So tau by I into integration of t is t square by 2 plus integration of c1 is a constant, so we have c1t plus another constant of integration c2 is equal to theta. So we have a relationship here, theta is equal to tau t square by 2i plus c1t plus c2t. We can see that this resembles to the general equation of a parabola, and therefore we can conclude relationship between theta and t is parabolic. The graph will be parabolic. But when we consider practical situation, theta will not be continuously increasing with time. It will have local fluctuations. The reason being momentary resistance to the motion of crank. So for very small intervals of time, there occurs some resistance. Then when more torque is applied, the theta further increases. And therefore, the graph looks something like this. Time versus theta. We have the graph overall, it's parabolic, but we have local fluctuations. Let's go back and mark the correct option. We can see option D has that curve with a relationship between theta and time being parabolic globally, but with local fluctuations. To learn more about machines and slider crank mechanism, you can refer to the NPTEL video Module 3, Lecture 1, Unbalance in Machines. The video is from the course Dynamics of Machines. Course is by Professor Amitabh Ghosh. He is from Department of Mechanical Engineering of IIT Kanpur. I hope this solution will help you clear your doubt. Thank you.